Alright guys, welcome back. We're going to finish up 7a. So we had just talked about using the multiplication rule to establish the total number of combinations, okay, when you have two or more processes back to back. And the next thing I want to show you, I don't know that your homework is going to touch on this, but I did want to talk about it for just a minute. Because if you ever take an introductory statistics class, and you're going to talk about this. So it is a probability distribution, okay? And what a probability distribution is it basically, it's like, well, commonly you'll see them, you can see them as tables, and that's what we're going to see here below, but what you do is you list every possible outcome, and typically, you know, like a table is used, every possible outcome, and then you list the corresponding probabilities to all those outcomes. You can identify outcomes that represent the same event and then determine the probability of each event. Okay, so basically it allows you to see how the probabilities are distributed. Okay, and that's why they call it a probability distribution table. And I'll show you an example. Oh, and also the sum of all the probabilities have to add up to 1, okay? And the reason for that is because if all these events are mutually exclusive, which means, you know, they two can't occur together or at the same time, then every single outcome or event is going to have its associated probability, and only one event will occur. And so if you take all the probabilities of all those events into consideration, they should sum up to 100%. Okay. So anyway, this is, let's see. Well, this is an example right here in which it says make a probability distribution for the sum of the dice when two fair dice are rolled together. And then what is the most probable sum? Okay. So think about the game Monopoly, if you've ever played that, or any sort of board game that requires that you roll two dice and you add them together, okay? So what we have on this top row represents the outcome of one of the dice, and then what we have over here is the outcome of the other dice, or the other die, okay? So for each one, you're going to get either 1 through a 6, right? And so what we have in the field here in this table are all the combinations. So, you know, if you roll a 1 and a 1, then the sum is going to be 2. Or if you roll a 1 and a 2, the sum is going to be 3, okay? Or if you roll a 1 and a 3, the sum is going to be 4, etc. And so what you do is you look at the event would be the different sums, okay? So like, if you look down here, these are the different events. So when you roll two dice, and you add together what's showing on both dice, then the sums are either going to be anywhere from 2 all the way to 12, okay? You'll get a 2 if you roll a 1 and a 1, and then you'll get a 12 if you roll a 6 and a 6, and then all the combinations in between, okay? So this is a probability distribution table right here. This shows you the probability of these different events. The probability of rolling a 4 is 3 out of 36. The probability of rolling a 9 is 4 out of 36. Some of these fractions haven't been reduced, but notice all these denominators are 36, and the reason is because there's 36 total outcomes, okay? Think about that multiplication rule again. There's 6 outcomes for the roll of the first die, and then there's 6 more outcomes for the roll of the second die. So using that multiplication rule, 6 times 6 is 36. So there's a total of 36 possible outcomes when you roll two dice. And so to figure out what the numerator here for the probability of each of these events, you just look up at this table. You can see there's only one way that you could get a 2, okay? So that's why the associated probability of that event, rolling a 2, or getting a 2, is 1 out of 36. But for a 3, you can get a 3 two ways. You could roll a 1 and then a 2, or a 2 and then a 1. The order doesn't matter. The sum is still going to be 3. So there's two ways that can happen, so 2 out of 36. And then you just kind of repeat the process. And you'll notice that it's the diagonals here that represent the different events. Okay, so you can see for a 4, there's 3 different ways that you can obtain a 4, so 3 out of 36. And so you just do that for all these different events, and if you were to add together all these probabilities, you would get a sum of 1. And that's because when you roll 2 die, one of these events has to occur. Okay? And then as far as the most probable event, it's going to be the event that has the highest probability. So 6 out of 36 is the highest probability, so that means that when you roll 2 die, you're most likely to roll a 7. Or in other words, when you play games that involve rolling 2 dice and you add them together, you're going to end up getting a 7 more than any of these other sums. Okay. Alright, so anyway, I just wanted you to see that. So that's an example of what we call a probability distribution. Okay. Alright, now the last thing we're going to talk about are odds. Okay, so you've probably heard this term before. People will say, what are the odds that I win $1 million? Or what if I buy this scratch-off ticket? What are the odds that I'll win $2,000? Okay, something like that. So really what they mean is, what's the probability? So the odds is basically more or less synonymous with the probability of. Okay, what are the odds that it rains tomorrow? Or in other words, what's the probability that it rains tomorrow? Okay. However, the odds are calculated a little bit differently. Now, if you've ever done any betting on horses, horse racing, or anything like that, games maybe even, sports games, they probably assign odds to the outcome, to different, like, the outcomes of the game. The odds, this is the way it's defined. It's the ratio of the probability that a particular event will occur to the probability that it will not occur. Okay? So we say the odds for an event means the probability that the event will occur divided by the probability that the event will not occur. Okay? So let's look at an example. What are the odds for getting 2 heads if you toss 2 coins? Okay? So this would be the probability that the event does occur. Okay? The probability of getting 2 heads, if you remember back in one of the previous slides up here, way up here, okay? Of getting 2 heads, that's 1 out of 4, right? Because there's 4 different outcomes when you flip 2 coins. So the probability of getting exactly 2 heads is 1/4. The probability of not getting 2 heads, well, that means getting either 0 heads or 1 heads, okay? Or in other words, if there's one outcome in which you obtain 2 heads, and that means the other 3 outcomes are not 2 heads. Okay, so in other words, the probability of not getting 2 heads is 3/4. Think back to what we talked about in the previous video, right here, the probability of an event not occurring. Okay, so if the probability that you get 2 heads is 1/4, then the probability that that event doesn't occur is 3/4. And so when you put these together, the 4's actually cancel, and these are the odds right here. So you say the odds for flipping 2 coins and getting 2 heads are 1 to 3. And what you'll notice is that if you add these two together, 1 plus 3 is 4. That'll give you the total number of outcomes. There are 4 outcomes, okay? One outcome will give you the 2 heads, and the other 3 outcomes will give you anything but, okay, 2 heads. All right, so that's odds for an event occurring. But what's more commonly listed, and this is done in horse racing, is they'll list the odds against an event. Okay? So what that is just the opposite, the reciprocal. It's the probability that the event will not occur divided by the probability that it will occur. Okay? And in gambling, the term odds on generally means odds against. Okay? And like I said, that's what's typically used. And let's see here. Well, so, you know, the odds against getting 2 heads would be just the opposite here. It would be 3 over 1. Because it would be 3/4 over 1/4, or 3 to 1. We'd say the odds against getting 2 heads are 3 to 1. Okay. Yeah, and it says that right here. We take the reciprocal for the odds for and find the odds against. Okay, so when you flip it, you get the odds against, and that would be 3 to 1. So the odds against getting 2 heads when you flip 2 coins are 3 to 1. And this just means that you're likely to not get 2 heads. You're more likely to not get 2 heads than you are to get 2 heads when you flip 2 coins. All right, let's look at one last example here. So an example in the context of horse racing. Okay. So it says at a horse race, the odds on this horse called Blue Moon, and if you're not familiar with horse racing, horses, the names that they give these race horses are typically, they're a bit odd, okay, no pun intended. They're not common names like Jack or Billy, okay. So Blue Moon is the name of this horse, and the odds on, which let me go ahead and say are the same as the odds against, okay. So the odds against Blue Moon are given as 7 to 2. Okay, so this means that you're more likely, it's more probable that Blue Moon actually loses. So anyway, what happens here, it says if you bet $10 and Blue Moon wins, how much are you going to gain? Okay, and the solution is this. So the 7 to 2 odds means that for every $1 or $2 that you bet, you're going to gain 7, okay? So for every $2 bet, you're going to get 7 using the odds right here. And so a $10 bet is going to be equivalent to 5 $2 bets. So you would get 5 times $7, which would be $35. And then you'd get your $10 back. So you're going to receive a total of 45. Now let me show you an easier way to figure this out. I set up a ratio, okay? So these are the odds against Blue Moon. And so when you bet, you're going to be betting $10, and then what you have up here, we can use X to represent the variable. So that variable represents how much you're going to win. So how much you win has to correspond to these odds over here, or in other words, these two ratios have to be equal to each other. Okay. So in other words, you're trying to figure out, well, what number up here would make this fraction equivalent to 7/2? Okay. There's a couple ways you can go about figuring this out. You could say, okay, well, what would I need to multiply 2 by to get to 10? Well, if I multiply it by 5, that'll take me to 10. And so to keep this fraction equivalent, I could multiply the numerator by 5 And 7 times 5 is 35, okay? And so that'll tell me what my winnings are going to be, okay? And that's the way I would do this, guys. Another approach is to look at it like it's an algebraic equation. And if you remember any of your algebra, to solve one like this, you can cross multiply. So you can say 7 times 10 is 70. And then multiply the 2 times x, and we write 2x. And then to solve for x, you divide both sides by 2, and you get x is equal to whatever 70 divided by 2 is, and that is $35, okay? So however you want to do it. And this will work, so always work regardless of what the odds are, okay? So let's say, let's think of another example. What if the odds were like 35 to 1, okay? And these are the odds that people typically bet. If you're going to really make a lot of money, you've got to bet on the long shot, okay? So the odds against this horse would be 35 to 1. So that means that the probability that the horse loses is 35 out of 36. Or in other words, the horse is most likely to lose. There's a very small chance that the horse could win. But let's say, let me see where my cursor is. Let's say that you bet $10 on this horse. Okay, so you put that in the denominator. And so you approach this the same way. You say, okay, 1 times what gives me 10? Well, 10. And so you multiply the top by 10, and you're going to get $350, okay? So when you have odds like this, you're betting on what's called a long shot. It's a horse that nobody really believes will win, but if it does actually win and you bet on it, you're going to win big, okay? A horse like Blue Moon, these are decent odds, 7 to 2, because you can see you end up making like 3.5 times what you bet. Okay. But usually the favorites, their odds are not going to be all that great. They're going to be like 7 to 2 or 5 to 2 or 3 to 2 or something like that. Okay. So when you bet on those horses, yeah, they're more likely to win, but if they do win, you're not going to make a whole lot of money. So, but anyway, any of you guys, that do horse racing or are interested in it and not quite sure how it worked, hopefully now you know. Okay? And that's about it for 7a, guys, and this will conclude chapter 7. So I've got 3 sections left. We're going to do 1 section in chapter 8, and then we'll do 2 sections in chapter 9, and then we'll have 1 more test that will cover 7, 8, and 9, and then we'll be getting ready for the final. Okay, so we're on the downhill. Basically. All right, so I'll see you in chapter 8.